Hello, Physics Nation. My name is Nate Larmond, and I would like to introduce 4 simple sun angle experiments. How long has our species been looking for patterns in the sky? Forever, I think, for, 1.5 million years, at least. Eratosthenes famously measured the size of the Earth using sun angle and some clever geometry. We're not going to do all of that. What we're going to do is just find some patterns in a physical system. Obviously the sun moves throughout the sky during the day, but it gets a little bit more complicated because the Earth is orbiting the sun. The sun moves throughout the sky according to the season too. So these are introductory experiments. The first one is from NASA, and we're going to hold a stick vertically and measure where its shadow is at different times during the day. Then, so that's the sort of kickoff phenomenon right here. Then NASA wants to study the consequences of this different sun angle. So they want you to model the sun with a flashlight, and we change the angle that it strikes the surface of the Earth and see how the area over which the energy of the sun is dispersed or spread out changes according to the sun angle. So this is like a meteorology experiment. First, make your sundial. Then, what are the consequences of this energy being more concentrated or less concentrated? So that's experiment 1, provided by NASA. Let's see, the hyperlinks are all down here, experiment 1. And then experiment 2 is University of Colorado at Boulder. They give a little more structure in terms of the data table, but it's just a sundial experiment. So I think you say gnomon, I'm not sure how to pronounce this word, this vertical stick right here. Anyway, it casts the shadow, and as the day goes on, you just keep track of time and position of where the shadow is, both the length of the shadow and the direction it's pointed. So you're supposed to line up your compass with north-south. Experiment 3 is also a sundial, basically, but this one's a college experiment. So Wenatchee, I'm not sure how to say this, out west, I think, in Washington State. Where are we? Yeah, so we're trying to determine what time of day it is. And again, they give you a data table. They ask you to do a little bit of trigonometry down here. So you can see they're using, some technical vocabulary, declination. Anyway, I'll let you try to figure out where your latitude and longitude is. The third one's a little bit more technical. And the fourth one is provided by Open Learning University in the UK. Where's this guy? And here we're going to make a different tool. This is called a quadrant. So this horizontal member right here rotates. And hang on, let me try to zoom in. This horizontal member rotates, and this is a plumb line. So you just put a protractor and you use the plumb line to figure out how high above horizontal or how far away from vertical this pointer stick is. So you're trying to align the quadrant to point directly at the sun and use the shadow cast by the sun to make sure it's aligned. Anyway, you can use the North Star too to figure out your latitude and longitude. Longitude requires a clock, basically. And those are 4 simple experiments. You don't actually have to do all 4 if you don't want to, but I'm going to do all 4. So feel free to just pick one and write it up in a lab report. So enjoy our astronomy lesson. See you in the next video. Thanks for watching.